Hi there, this is Dr. Hisham Said. In this video, we'll introduce the topic of engineering economics. We'll define what's really engineering economics and why we engineers, civil engineers and other engineers, need to know about economics and apply it in our practices and see it in the play of economics in the short and long-term decisions. So what is engineering economics? It's engineering and economics. You apply economics, the principles of economics into the practicing of engineering and evaluating design alternatives. And why it's important? Because we engineers develop designs considering multiple factor and evaluation criteria. So we design systems based on their technical performance, environmental impact, durability, and of course economical aspects. So if you're learning engineering, probably you'll be doing that in a ABET accredited institution. ABET is the entity that certifies the programs that teach engineers. And the idea here, they define the profession of engineering by this definition shown here. So it's the use of mathematics and natural sciences to develop, systems that are economically, beneficial to mankind. So economics here is very important part of practicing and learning engineering. A couple of examples here. So things about how engineering economics play a role in making engineering decisions. So first, you need to decide is this engineering decision worthwhile, or this engineering project worthwhile? So you would ask, is it worthwhile to build a solar energy plant in somewhere like in Alaska, where you don't have much solar exposure? So deciding from the beginning, should I build this or not? Or should I make that project or not? And then once you make a decision, let's go for it. Then within the project, when you design it, you make decisions, should I select this system or that system? So what type of concrete batching plant should you use to buy or to buy for your company? So engineering economics entail different steps. So you have to formulate the problem and estimate it and evaluate the economical outcomes of the different alternatives you have. So, and engineering economics analysis follow a process that's similar to a general engineering analysis and design. So you have to formulate the problem. You have to define the objectives and boundaries of the problem. You have to analyze the problem. So you have to determine the description of the problem and the criteria and constraints. And then you have to search for alternative solutions to the problem. You have to be creative in seeking solutions and alternatives to consider. And then you select the alternatives based on evaluation criteria, including economics. And then the last step is to specify what alternative or solution you're proposing and communicating that clearly in a way that is convincing to others. So in this course here, we'll more be focused on selecting the process of selecting solutions based on economics. Steps 1, 2, and 3 will be kind of formulated for you in the course assignments. In the project assignment, probably will have some role and some say in doing some of the steps 1 to 3 to formulate a problem. So you will have some freedom to try them out instead of being given a problem that's formulated for you. So still we didn't say what does economics here entail. It entails a lot of calculations of dollar values and dealing with rates, and but we'll see here an example of comparing alternatives. So you're comparing between alternative 1 and 2, and you're only focused in 1 year here. And the alternatives we have are for earth moving equipment, You are given here the data for monthly leasing this equipment, its fuel consumption, and hourly maintenance costs. So it's dollar per hour of use. Now we're given here the fuel cost, dollar per gallon, and kind of the equipment usage over a year. It works 6 hours a day, 5 days a week, and there are 50 weeks per year on average. And we need to decide which equipment or alternative to go with. So probably you could do that on the back of an envelope kind of calculations. You don't need really a course, but it's just an introductory example here. So first of all, you have to calculate the total usage per actually year here. This should be per year, so I'll fix that because we're calculating here everything per year. So that's per year, and everything here is per year. Sorry for that. All right, so we have everything per year because we are given the usage per year and we're evaluating per year. So going back here, so we have 6 hours per day, 5 days per week, 50 weeks per day, per year. So we have here 1,500 hours per year. The lease cost is given to us dollar per month. So the first one is $1,000 per month times 12. That will bring you the annual lease cost. Fuel cost, you have the 6.1 gallon per hour. Multiply by the hour per year, then you get up to the gallons per year. And then multiply by the dollar per gallon, you get the fuel cost per year. Maintenance cost, you're given dollar per hour, multiplied per hour per year, you end up with the maintenance cost per year. Add up, this is the total cost for the alternative 1. Alternative 2, do similar calculations, end up with 58,440. And based on economics here, you pick the least cost. So you select alternative 2. So that's an example. Focus on an equipment. You have 2 alternatives, and you only focus on 1 year. Now, what happens if this equipment will be used more than a year? So now your decision is expanding, covering a longer period of time here. And the question is, will the analysis be valid? Will you still do this similar type of analysis? Maybe kind of you say, if I calculate per year, then it should be like that for 10 years. So that's maybe in some cases, but generally you actually need to do more than that for different reasons. So the first reason we will kind of discuss or think about it, is I will explain it by an example. So you have $1,000 and you are given the option of keeping it now with you or give it to me and I will give it back to you in a year as $1,000. So you keep it or give it to me and I will return it in 1 year. It's still the same amount. You don't need the $1,000, so kind of you're lending it to me and I'm getting it back to you exactly as it is in a year. And you don't expect need the money while you wait for it. So it's just an extra cash you have for you. So the question is, what do? You keep the money or you give it to me and give it back to you in a year, the same. So think about it for a moment. Then if I change a little the arrangement, so you keep the money with you or you give it to me and I will return it back to you in a year as $1,100. Same conditions apply. You don't need the money, you don't have a need for it now. So think about it and compare this to your decision that you made before. All right, so moving to the next third scenario here. If you have the $1,000, do you want to keep it or give it to me and return it in a year $5,000? So which way you would like to go here? Take a moment to think about it. All right, so probably like your keenness to keep the money is decreasing. Because if $1,000 will stay the same with me and return it back to you the same, there's no incentive to give the money, right? Except unless I'm your friend and you want to help me with no interest from you or return back to you. But if I'm not friend, I'm asking just for a loan for a business, then you will expect more money back. But why is that? Why when we deal with money and over time we expect the money to grow? So money value changes over time. This is kind of the norm. Basics of economics is $1,000 now should not be the same $1,000 in a year. Possible reasons: inflation. So $1,000 buys me a very nice iPhone now. Probably in 5 years from now, if the same iPhone with no technology changes, I will buy it with 1,500. So this 1,000 will not buy me the same thing that I buy now. Will not buy the same thing in 10 years from now. So that's the loss of purchasing power. That's inflation. But another reason, which is kind of related to that from economics theory, is the earning power. If I have $1,000 now, I have a power of earning more money from it through different venues in different ways. This is called the time value of money. So there's a difference between inflation and the time value of money. Inflation is you lose the purchasing power of the dollar, but time value of money, you gain more dollars from the dollar, kind of. That's the earning power. So other names for time value of money is opportunity cost, so or attractive rate of return, or the thing we all know about is interest rate. But it is literally the time value of money. You have to think about it beyond just interest rate. It is the time value of money, the earning power of your money. If you give this money to someone else, you're giving away your earning power. So that's the opportunity cost here. The cost of lending money or giving away money. It's you're losing the opportunity to invest the money and earn from it. Or use the money in your own investment, your own project, and get out more profit out of it. So two things affect the money over time. It's the inflation and its time value. So this is what economics is. This is what we will do in the course of engineering economics is studying the time value of money in different forms that are represented as cash flows. So we need to represent every alternative, either it's equipment or project, as a cash flow. And I need to do that in a visual way that we can understand, we can communicate and exchange our understanding of the project in a clear way. So cash flow is a diagram similar to, if you're engineering kind of the force diagrams, the direction of the arrow matters. If it goes up, it's a positive cash flow. If it goes down, it's negative. The horizontal line is the timeline. 0 means end of year 0, beginning of day 1, and you keep going to the right, increasing in time. Arrows can go up and down depending on if you're purchasing an equipment, you have initial cost. If you're maintaining the equipment, then there's little cost over the years. If the equipment generates income for you, then there are positive arrows going up. So cash flow is a very intuitive way to represent the economical data of a project or alternative. So let's illustrate now kind of how cash flows help us in some way compare between alternatives and kind of get an idea which one actually is better for us. So we have here alternatives A and B. CF stands for cash flow, end of year. This is the cash flow that I have. And if you add up here just the algebraic sum of all the numbers, you have both of the investments. I'm investing 100,000 for both. I'm getting cash positive, and I'm ending up with, at the end, a positive net of 50,000 for both. So as a net, it's the same. But cash flows, visualize these now and think of which one is really better, alternative A or alternative B. Give you a moment to think about it. And maybe you can look by the numbers, but cash flows will tell you the whole story here. So if you look at cash flow of alternative A, you will find that you're getting less money at the beginning and you're getting more money at the end. Again, the net is 50,000 profit at the end. But here you get more money upfront than later. So kind of you're considering the time value of money. The more money I have early, the more ability that I will have to invest it and will have more earning power because I have more cash. So this means that this alternative is better, alternative B. Although that the net algebraic, again, without considering any time value of money, both would initially look similar. But cash flows are not quantitative. Like we engineers love to calculate things. Like tell me by number which one is better. Don't tell me look at the diagram and see the arrows going up more early. So we need to quantify economically which one is better. So this is what we're going to cover in the next video. How to calculate interest, how to calculate the accumulation of value over time or deduction of value over time when we go backward in time. So we will cover that in the next video, introducing the concept, and the many videos to come to apply that in comparing alternatives and analyzing complicated cash flows. So that was the introduction to engineering economics. Take care. I will see you in future videos.